In this video, we will be working through question 3.3 and 3.4 of Math Lit Paper 2, November 21. If you would like to download a copy of this question paper, the link is in the description below. 3.3. CD bought the bookshelf at a discounted price because the backboard, which covers the entire width and height of the bookshelf, needed painting. She decides to do the following. Remove the backboard. Paint the back of the backboard with a single coat of paint. Paint the front of the backboard with 2 coats of paint. Nail the backboard to the bookshelf. 3.3.1. Calculate in square centimeters the area of one side of the backboard. As a side note, a backboard is a thin board attached to the back of a shelf or a cupboard that helps to keep the shelf square and prevents the shelf from folding in on itself. From the illustration in question 3, the shape of the bookshelf is rectangular, so the backboard will have the same shape and dimensions as the outside dimensions of the bookshelf. We are given a formula for the area of a rectangular in the note as length multiplied by width. When we remove the backboard from the shelf and place it on a flat surface for painting, the length of the backboard will be 165 centimeters. This value was calculated in question 3.1.1. The width of the backboard when placed on a flat surface will be 80 centimeters. This dimension corresponds to the height of the bookshelf. The area of the backboard is the length of the backboard of 165 centimeters multiplied by the width of 80 centimeters, and this gives us an area of 13,200 squared centimeters. 3.3.2. Convert the answer in question 3.3.1 to square meters. We should know that 1 meter equals 100 centimeters, but area is measured in squared units. So 1 square meter equals 100 centimeters times 100 centimeters, and this equals 10,000 square centimeters. Therefore, 1 square meter equals 10,000 square centimeters. From question 3.3.1, the area of the backboard was determined to be 13,200 square centimeters. So the area of the backboard in square meters is equal to 13,200 divided by 10,000, and this equals an area of 1,32 square meters. Question 3.3.3. 1 liter of paint covers 6,9 square meters. Determine, rounded to 2 decimal places, the number of liters of paint required to paint the backboard completely. From question 3.3, the back of the backboard will be covered with 1 coat of paint and the front of the backboard will be covered with 2 coats of paint. This gives us a total of 3 coats. From question 3.3.2, the area of the backboard was calculated to be 1,32 square meters. So the total area to be painted is 1,32 square meters multiplied by 3, and this equals a total painted area of 3,96 square meters. Since 1 liter of paint covers 6,9 square meters of area, the number of liters of paint required to paint the backboard completely is 3,96 square meters divided by 6,9 square meters, and this equals 0,57391 liters of paint. Rounded to 2 decimal places, and this gives us a volume of 0,57 liters of paint. 3.3.4. CD stated that one 500 milliliter can of paint is sufficient to paint the backboard completely. Verify with calculation whether a statement is valid. We know that 1 liter equals 1000 milliliters, and from question 3.3.3, the number of liters of paint required is 0,57 liters. So the number of milliliters required to paint the backboard completely is 0,57 multiplied by 1000 milliliters, and this equals a volume of 570 milliliters. We see that the number of milliliters of paint required is more than a 500 milliliter can of paint, so a statement is invalid. 3.4. CD wants to organize her documents in files. She was informed that you can store files separately, single files, or in a filing box as shown in the picture below. We are given a picture of a filing box with files in it. The width of the filing box is 345 millimeters and the width of a single file is 8,1 centimeters. We are instructed to use the information above to answer the following questions. 3.4.1. Determine the maximum number of filing boxes that could fit in one shelf, which is 162 centimeters wide. The width of the shelf is given in centimeters and the width of a filing box is given in millimeters. So the first step is to convert one of these units to the other. We can choose to convert the width of the filing box from millimeters to centimeters. There are 10 millimeters in 1 centimeter, so 345 millimeters is 345 divided by 10, and this gives us a width of 34,5 centimeters. The maximum number of filing boxes that could fit on one shelf is 162 centimeters divided by 34,5 centimeters, and this equals 4,696. Since we can only fit whole filing boxes on the shelf, we have to round this number down to the nearest whole number, which is 4. There will be some space left over on the shelf, but it will be too small for another filing box. 3.1.2. Calculate the difference in the number of files that she can place on one shelf if she packs the shelf with single files rather than the filing boxes. If she decides to pack the shelf with single files, the number of files that you can fit in a shelf is 162 centimeters divided by 8,1 centimeters, and this equals 20 files. From question 3.4.1, the number of filing boxes that can fit on a shelf is 4. And from the picture in question 3.4, we see that we can fit 4 files in a filing box. We can also confirm this mathematically by dividing the width of a filing box by the width of a single file. If you would like to confirm this, you can give it a try by yourself, but we will accept that there are 4 files that can fit in a filing box. So the number of files that can be packed on the shelf with filing boxes is 4 times 4, and this equals 16 files. So the difference in the number of files is 20 minus 16, and this equals 4. 3.4.3. Give a possible reason why CD would prefer the filing boxes. One of the reasons that can be given is that filing boxes are neater than single files, so neater storage. Other reasons that are acceptable are it is easier to separate the files accordingly. It prevents dust on the documents in files, or to categorize files or to organize files. 3.4.4. CD bought filing boxes to pack the top shelf completely. She could not remember in which file she placed a document. She randomly chooses one of the files out of the filing boxes. Determine as a percentage to 2 decimal places the probability that the file she chooses will contain the document she is looking for. With filing boxes, the top shelf will have 16 files. The probability of randomly choosing a file that contains the document she is looking for is 1 out of 16. As a percentage, this is 1 over 16 multiplied by 100, and this gives us a probability of 6.25%. And that's going to be it for question 3.3 and 3.4. If you found this video helpful and you'd like to learn more, you can check out this video next.